That's horrible. That's horrible. There it is. Alrighty, let's go ahead and continue on here. So what we're going to do in the next section here is get into... Where'd the mouse go? The rest of this testing discussion. So we're going to look at acceptance test driven development, and we're going to start that discussion by looking first at acceptance criteria. So you guys remember when we're talking about user stories, I mentioned that acceptance criteria is the way that we clarify all the different scenarios under which this particular story might be used. So acceptance criteria are the conditions that must be met for the story to be considered complete, and usually created as part of that customer collaboration conversation where we're asking the customer what it is that they're looking for, and talking about all the different scenarios, all the different use cases where that story might be used. And it's my preference to have those acceptance criteria written in Gherkin format so that no matter who writes them, whether it be the product owner or the analyst or one of the team members inserting additional acceptance criteria as we discuss them during sprint planning or whatever, those acceptance criteria will always be written following some standard format. Now, again, it doesn't say anything in the Scrum Guide about having to write the acceptance criteria in Gherkin format, but if you do write the acceptance criteria in Gherkin format, it's much easier to make sure that these three important questions get answered. So let's take a look at a sample. So here's a story sample. As an accounting user, I want to compute the sales tax for California, Texas, and Virginia so that I can remit this to the government. So that's our user story, basically saying that we want to be able to calculate the sales tax for the different states that we do sales or do business in. The acceptance criteria here, just written in basic sentence format. When I enter the state and sales amount, the system returns the sales tax to be collected. Now, that's just free-form acceptance criteria, not following any particular format. So I'm of the thinking that since our user story follows a specific format, as a who, I want what, so that why, our acceptance criteria should also follow a similar format. So for that, we have Gherkin. Again, a gherkin is just a type of cucumber used to make pickles. So it seems fitting that the scripting format known as Gherkin is used in the tool called Cucumber. So here we have that same acceptance criteria written in the Gherkin given when then format. Given a certain scenario, when I perform a certain action, then I expect to see these testable results. So that's that sales tax scenario from the previous slide. The acceptance criteria for that is here written in Gherkin format. Given a valid amount and state, when I submit these values, then the sales tax to be collected is returned. So basically the same thing as we said before, but now structured into that Gherkin format. Now, to be able to run these tests, we're going to have a few input values. In this case, we need an amount and a sales tax, an amount and a state, and then the tax that we expect to be returned from the system. So our input wouldn't include the rate. The rate is supposed to be inside of the system. So our input would be the amount, the state, and what we expect to be returned. So we basically say, given a valid amount and state, 1,000 in California, when I submit these values, then the sales tax to be collected is returned. This is obviously an old slide because I'm pretty sure the sales tax is much higher than 8.75 now. But assuming that the sales tax rate is 8.75, then we should get 87.5 or 50 returned from running that function. Now the same is true for all these other executions. Passing the value, the amount, the state should give us back the sales tax that we have calculated there. Now, when we write our acceptance tests first, just like when we write our unit tests first, what we are then talking about is test-driven development, or in this case, acceptance test-driven development. So the way that ATDD fits with TDD is because the automated acceptance tests are typically a combination of some of the smaller units. We'll usually have multiple unit tests that are used to make up a single acceptance test. So you can see the flow here is we discuss with whoever we need to discuss it with, the customer or the analyst or whatever, and through that discussion we distill the acceptance criteria, and from that acceptance criteria we build the acceptance tests. And once we have an acceptance test, then we'll go and do all of the unit tests that are necessary to get the methods done that the acceptance test is testing. So again, with our tester and development demo in the last, before lunch there, or whenever we did that, after lunch I guess, we had the 4 core methods: push, pop, peek, and is empty. Once we have those 4 core methods defined, then we can run all sorts of different acceptance tests using those 4 core methods without having to do any additional coding. So that's kind of what this cycle looks like here. We build the acceptance criteria or acceptance test. We develop by doing red, green, refactor, or failing test, passing test, refactor, and run the test again. And after we've done all of that, then we can run our acceptance tests. And at that point, our acceptance test should pass. All right, how are we doing on time here? 2:40, we got about 2 hours left. I think that's enough time that we can do our automated acceptance test with Cucumber as a group. Normally in this 2-day version of the class, I do the Cucumber lab as a demo, but I think we've got enough time that we can kind of go through that as a group, and if you guys have any issues or get stuck, we have time for that. So let's jump back into our virtual machines here. And in our virtual machine, we want to load Eclipse. By the way, for this one, there are no instructions in your book, so you have to follow along. But if you did want to do this one after class, I can send you a link to the detailed instructions. In fact, give me a second, I'll do that now. It's not over there, over here. I will drop the link to the Cucumber acceptance test demo into the chat window here in just a moment. Oops. Oh, there it is. I was typing and nothing was happening. Page was still loading, I guess. So Cucumber. Run. All right, so I'm going to drop this link into the chat window. You don't need it right now, but if you want to come back and do this later on, this is where those instructions are. And if you look at the instructions on the post here, we basically have step-by-step instructions, although this assumes that you already have Cucumber installed. So if we click this link here, we can go to the previous post that shows us how to install Cucumber. Pretty straightforward process. We're just going to go into the Eclipse Marketplace. So let's go ahead and do that. In our virtual machines, we're going to go into into Eclipse, and the Marketplace is under the Help menu. So in the Help menu, we're going to select Eclipse Marketplace. Oh man, I left my lemonade upstairs. And in the Eclipse Marketplace, we are going to search for Cucumber. And we will see the Cucumber Eclipse plugin, which we can then choose to install. I think the Cucumber install might require us to not reboot, but relaunch Cucumber. I keep wanting to call it Eclipse Cucumber. Might require us to relaunch Eclipse so that the plugin loads completely. If I remember correctly, it does require an update. We have to also accept the license agreement. Okay, maybe we don't have to restart Eclipse. All right, good. So now we have Eclipse installed. I keep interchanging them. Now we have Cucumber installed in Eclipse. So we can continue on with the instructions here. And all we're really going to do here is, we've already got our Maven project. We already did our, we did our 4 core methods in our stack class. So what we're going to do now is tell Eclipse, or in our Maven project, that we want to run Cucumber. And the way that we're going to do that is we're going to create a Cucumber runner file. And I'm just going to copy this stuff here and paste that into my Cucumber runner. Pretty standard. Pretty much every project that I do that uses Cucumber, I just use the same code snippet. So we're going to go into the source test Java folder. And in that source test Java folder, we're going to create a file called Cucumber Runner. So let's go to our virtual machine. Oops. I guess it wasn't quite done installing Cucumber yet. It was waiting for me to click OK or install or whatever. But so in the I knew it needed to restart Eclipse. So after we restart Eclipse, we're going to come back to the source test Java folder and we'll create that Cucumber runner file. Let's restart Eclipse first. We don't need that. Okay, we're back in Eclipse. In our Package Explorer, in our Stack app, we're going to go to the source test Java folder and we're going to add a new class. And we're going to call that new class Cucumber Runner. And then we're just going to highlight everything that's in here, and I'm going to paste what I pulled out of that web link. And you can see we got a bunch of red squigglies here. But we're not going to do anything at all with those red squigglies. We're going to just leave those red squigglies for now, because the way that we're going to get all the stuff that the red squigglies refers to is by going and modifying the POM file and updating our dependencies. So if I jump back over here to the article, the blog post here, we created our Cucumber runner. It's got a bunch of red squigglies. To get rid of the red squigglies, we're going to go into the POM file and add our dependencies. Now here's the dependencies that we want to add. I can add them by just doing a copy and paste. So I'm going to grab that and copy all of it. But I can also add them manually by going into the POM file. Just going to double click on the pom.xml file. And if I go to dependencies, I can do add dependency, and I can say I want JUnit as the group ID, JUnit as the artifact ID, and 4.12 as the version. My scope, I'm going to make it test, and then I'm going to click OK. So now you can see we've got one dependency added. If I go look at the pom.xml file itself, you look along the tabs here from dependencies, there's now pom.xml. I can look into that pom.xml file and I see I have a dependency section that has a dependency called JUnit, and it's version 4.12, and the scope is to compile. But I don't need that, so I'm just going to highlight over all of that I just created, and I'm going to paste in the dependencies that I pulled out of the blog post. Less typing means less typos. Same thing every time. And once we save our pom.xml file, we should be able to see in our Cucumber runner that our red squigglies are now gone. Okay, so now we should be able to continue on. Not sure what the deal is with that JUnit there. That's not a red squiggly though. So now that we've got that, we should be able to go into our source test resources folder. Jump back over here to the post. We should be able to go into our source test resources folder and create our stack feature.feature file. And our feature file is basically just going to consist, well, first off, it's going to give us a sample. Let's take a look at that first. But then we'll copy and paste the acceptance criteria from that service reservation solution file that we looked at earlier. So let's first create our feature file. Under source test resources, we're going to create a new file, just a generic file, because we want to control the extension. And we're going to call it stack features.feature. And by creating a file with the feature extension, because we loaded Cucumber, it knows that feature files are part of Cucumber, and Cucumber has a template for feature files. So here is our Cucumber feature file template. And if I'm being honest, the first time I ran this years and years ago is when I discovered this option to use an outline to insert values into these placeholders using this outline. So the first row is the variable name, value, status. And then all the rows that come after that are test instances. So first run it with the name 1 and the value 5, and status we expect to be success. And then run name 2, 7, and we expect that to be a fail. We're not going to use any of that though. We're going to jump back over here to DevOps Classroom and our service reservation solution. And I'm going to go to the board or the backlog. In the backlog, I'm going to find, as a user, I need to stack stuff so that I can move it around. And inside of that user story, I'm just going to highlight all, Control A, of the acceptance criteria, Control C, and copy it. And I'm going to go back to Eclipse, and I'm going to select all of the text that's in this file and paste over the top of it with the stuff that I just pulled out of the service reservation solution in Azure DevOps. Now, it looks like everything is great. We've got everything that we need here. But if I try to run these tests, it's not going to work out very well for me. So I'm going to do a run as, cucumber feature, save all my files. And it's saying that we don't have what we need. It's basically saying this feature file includes all of this stuff here, but none of this stuff has been implemented. They are all undefined scenarios. And then it says you can implement these missing steps with the snippets below. So what we are going to do now under source test Java is we're going to create a step definition file. All right, so if we come back over here and look in the instructions, we want to go and create in the, what do you call it? In the source test Java file folder, a file or a class file named stack steps. All right, and then we're just going to insert this code into that file. If I remember correctly, some of this code doesn't quite match up. You know what? Instead of doing that, I'm going to grab it right from Eclipse. I don't trust that. So I'm going to grab it right from here. And then we'll write it ourselves instead of just copy and paste. So I'm going to copy that from the output of Eclipse. And then in source test Java, I'm going to create a new file, new class called stack steps. And in that file, in between here and here, I'm going to paste the stuff that I just pulled from the output window. And you can see it does not like that. It's got red squigglies because it doesn't know what given, when, then are all about. So just like we did earlier, I'm going to hover my mouse. And I'm going to use the code generation tools to import given. Then same thing with when. Import when. Same thing with then. Import then. Now the red squigglies should be gone from all of the file here. And then we're just going to go through and do the same thing that we did earlier. What does it mean to have an empty stack? Well, first, that means we have to define stack as a variable. We'll also need a string actual as a variable, and we'll need a Boolean variable. A Boolean variable called isEmpty. I think that's everything we need. So, given an empty stack, what does that mean? Well, that just means that we have an empty stack. So we're going to say stack equals new stack. Now we have an empty stack. So whenever the text given an empty stack is encountered, it'll run this code. When I check to see if the stack is empty, well, that just means that we have to run the isEmpty method, but we're going to store the results in that module level variable that we created. IsEmpty equals stack.isEmpty. There we go. And then the empty check should be true. So, or empty check should be whatever is passed in. So for that, we're going to do an empty check. I'm going to use an assert equals here. Oops, that A should be not capital. And with assert equals, I'm just going to compare the actual value, which is empty, the Boolean variable we created, to the expected value which in this case is going to be that string. That's right, expected comes first. That should be that string, but we're comparing a string to a Boolean. So that means that we have to convert the string to a Boolean first. So to do that, we're going to use Boolean dot parse Boolean, and we're going to parse that string. Oops. The string parameter called string. So we're going to compare string to isEmpty. We're going to convert that string. Now the reason it says string there is because if we look in the feature file, oops. There you go. Sorry, fat fingered that. If we look in the feature file, what's going on here? Oh, it doesn't like that one either. We didn't import assert equals yet, so let's do that. In the feature file, we said then the empty check should be, and then we have a quoted string here. That means that we can change that value from true to false, and it'll run the same code. So since sometimes it's true and sometimes it's false, we want to make sure that we're using an equals as opposed to an assert true, because then we have to have a totally separate statement for when it's false. So because we put the Boolean in a string parameter, we just convert it from a string to a Boolean, and then we do an equals comparison to see if the two Boolean values are the same. All right, moving right along, given a non-empty stack. Here, we're going to create a new stack equals new stack. And then we're going to do a stack dot push. And we're going to push onto the stack some value. Doesn't matter what the value is. We just need to put something onto the stack so that the stack is now not empty. And then this is a typo. So this is why it's important that we're consistent with our grammar. If we go back to our feature file, stack feature.feature, you can look here and you can see that the first time we said given an empty stack, grammatically correct. Then down here we said given a empty stack. It doesn't know the difference. It doesn't know anything about grammar, so it thinks that you mean something different. All we need to do here is change this to an and, make it consistent, and then we don't need this extra step over here, given a empty stack. So we can get rid of that now. Did that on purpose just to illustrate what happens if you aren't consistent with your statements. So now we've got that. The next thing we're going to do here is when I push a string, whatever the string value is, onto the stack. So we're going to say stack.push, and then we're going to push that string. And when I pop a value off the stack, there we're going to say actual, the actual variable equals the return value of stack.pop. Then the result should be, now this time we're comparing the value that we pushed with the value that we popped. Do we need an expected there? When I push a value onto the stack. Oh yeah. Then the result should be, we're going to do a assert equals. You got to spell it right. Man, I got that all wrong. Assert equals, there we go. In our assert equals, we're going to compare the expected value, which is going to be our string here, to the actual value that was returned. Same thing with peak. we're going to do the same thing that we did for the pop function. We're going to do actual equals stack dot peak. And I think that's it. So you can see here with our acceptance tests, we're basically doing the same functions that we did with our unit tests, running those 4 core methods: push, pop, peak, and check empty or is empty. So unless something has gone horribly wrong, we should be all set now. Run our cucumber feature. Did I get it? So we can go to JUnit and rerun all of our tests. No, it's mad at me now. So let's go one more time. Run as cucumber feature. What's going on here? Let's try running my tests. Oh wait, it's not even saving my files. Save all. There we go. There we go, that's better. Okay, so now we got 2 failed, 31 passed. Let's look at our JUnit test explorer here. How come we have nothing? Let me clear out all these extra files here. Alrighty. Let's try our cucumber runner. Run it as JUnit tests. There we go. That 33 skipped. Still says they're undefined. It looks like it doesn't like my path. So bear with me just a moment here. Oh, I told it was going to be in the steps namespace. Let's just remove that. I didn't put it into a proper namespace, so it's out there in the open. Let's try that again. There we go, that's better. So now we have 7 of 7 tests and 2 failing. And if we look, the tests that are failing are the multis, right? And they're failing because we have that logic error in there. We have multi push pop failing, and it says we expected item 2, but what we got was item 1. Multi push pop 2, we expected item 1, but what we got was big ending. Now, I told you guys earlier that when we wrote this code, we purposely included a logic error so that we wouldn't find the logic error with our unit tests, but we could find it with our acceptance tests. Remember, if we go back and we look in our package explorer and we bring up our stack tests and we run these tests, all of these tests are passing. And these tests are passing, all of these tests are passing because we didn't do test 5 and test 8, the 2 multi-tests. So now that we've made it through our core testing, thinking that we did everything great, we run our acceptance test for acceptance test-driven development, we have 2 tests failing. That indicates that there was a logic error. Now, the easy fix for the logic error is that we just go back to our stack class in source main Java. And in our stack class, instead of doing, where is it, stack.add, we do stack add added at index 0, comma. So now instead of adding, what the array list does is it appends all the items to the end or the bottom of the array list. What we want it to do is be a stack. So we want to put things on the top of the stack. So we have to just tell it to add it at index 0. And just by making that one minor change, we have fixed our logic error. So we can come back here and run as JUnit tests, and we should get all of our tests passing. So there you have it. That is Cucumber in a nutshell. Running our Cucumber automated acceptance tests in our Maven project inside of Eclipse.